Hey, Algebra 2 students, welcome to Day 6 notes. We're going to be looking at describing functions using some new vocab words. So we're going to describe functions using words like when is the function increasing, when is it decreasing, when is it constant. So a little bit of a continuation of describing functions like we've done in the past. And we're going to look specifically at functions called piecewise functions. So these are kind of our two big items for today's video. So for this first problem, you've got a picture, and you can do like a quick sketch of it in your notebook with those three labeled points. And a lot of the questions that we're going to see, starting with this homework assignment that you guys are going to be doing in class, is it will ask you when is the function f of x, right? So it's referencing this picture. When is it increasing? When is it decreasing? When is it constant? So I'm going to do increasing. I'm going to do decreasing. And constant. And you can think about this of, like, this is representing money, right? Increasing has a positive slope. Looking like left to right, it would be going like up. Decreasing has a negative slope, right? Remembering slope, left to right, it's going down. Constant has a slope of 0, right? 0 slope. And we're going to be writing these using our interval notation. So for instance, if I'm looking for when is it increasing, I'm going to do some highlights in blue. So it looks like it's increasing in this section and in this section. And so if I'm talking about the increasing, I want to talk about those sections, and I'm going to be using the x coordinates specifically. So I'm going to use these x coordinates. So I would say it's increasing from negative 0.4, I'm just going to round, to 0.5, and just kind of round it to there. Then the second chunk is from about 2.1, and then notice it would keep increasing, right, because there's an implied arrow there, so infinity. And so you want to be using interval notation. For this, we are always using parentheses. So like maybe some little notes on the side is use interval notation, and always use parentheses. The reason why we're doing parentheses is if I think about where it's decreasing, kind of on the flip side, here are some decreasing areas in pink. Notice that this point right here at the top, at that x value, it's kind of a point where we're switching from increasing to decreasing. So because of that, we don't want to say we are increasing at that specific point, because when I talk about my decreasing, and I'm just going to erase this stuff here for a sec to have room. When I talk about my decreasing areas, I would be talking about it decreasing from that same value of 0.5 to 2.1. So notice, because we're using those same x values to talk about increasing and decreasing, we want to make sure that we're not saying it's doing two different things at one point. Some students have trouble sometimes remembering to use x rather than y when describing this. Notice if I talk about like a height, and so the reason why we talk about these intervals using our x's is because notice if I talked about like a range of y is 1 to y is 2, notice that in that range of y is 1 to 2, like in between these lines, notice the function is both decreasing and increasing between heights of y is 1 and y is 2. So keep that in mind. We also have a second decreasing zone. I did not capture this zone over here. So that second decreasing is from negative infinity, and then I stop at the x value of negative 0.4. And then we actually don't have any constant sections. There's nowhere where you have like a flat line or a slope of 0. You would be looking for something like if there was a graph that maybe looked like this, like here, and then maybe it leveled off and then went down. The constant area would be right there where you have a horizontal line, a slope of 0. So that's what you would look for. And then something else you sometimes will want to think about is these points that are kind of the crux points are points where we switch. Those are your maximums and minimums. So your maximums, I'll kind of highlight those maybe in orange. Your maximums are points like right here, right? Those are points where it's like the highest point in that particular zone. So a maximum point will be like 0.5, 3 point, maybe I'll round it up to 7. Whereas a minimum, maybe I'll use pink. So minimums, I'm going to make kind of the pink color. And minimums are like the lowest points in those areas. So negative 0.4, comma 2.4, and 2.1, negative 1.1. So those are what we call maxes and minimums. Don't worry too much about local minimums versus absolute. What that means is it's saying like, you know, this might be a maximum in that vicinity, like in that area, it's the highest point, but it's not the highest point that the graph hits overall. Whereas like this point down here, that's actually the lowest point that that graph ever will come. So if you wanted to describe it, you could call this one, it's like the absolute minimum, no matter what. Whereas sometimes we talk about minimums like the other one, and it's just the minimum, like this one, it's just the minimum in that vicinity. So that one would be called technically a local min. Not the lowest overall, but it's a minimum in the general area. Same thing as this one. This one would be called a local max. Because notice the graph keeps going up, so that's not the biggest overall point. So we use those vocab words and we use the maxes and mins to really talk about where we are switching around from increasing, decreasing, right? Those are going to be useful points for us. And so we're going to go on to our second goal, which is graphing piecewise functions. So a piecewise function, I think of them as puzzle pieces. Really all it is you graph 3 separate functions, and you only graph them for certain bits. So first I'm going to graph this line, and this line, and I'm going to use 3 different colors. So go ahead and pause the video and graph those lines, right? You should have just watched a video on slope-intercept form that has kind of refreshed you on that. Okay, so I've graphed my 3 lines based on slopes and y-intercepts. Now, what a piecewise function is it's going to take these 3 functions, but it's going to take pieces of each of them and kind of put it together to make one big overarching graph that we're going to look at. So the blue graph, we only want to graph it when it's smaller than or equal to 0, which means I'm only going to be using this chunk. So I'm just going to erase these points, and we're only focusing on that section over here. Same kind of thing for the other ones. The pink one, I'm only doing it between 0 and 4. So I'm going to find my point at 4. Looks like here is where my point would be at 4, like right here. And I'm going to have that point filled in. And I'm going to erase the edges, right, because I'm kind of stuck between those points. Now, one thing to keep in mind is notice I'm not actually allowed to equal 4. I can get really close to it, but not quite touch it. So just like we did on the number line, since I can't equal 0, I'm going to have an open circle there. But notice I have a closed circle at 4 because I can equal. So make a little note for open circle. Okay. And then for the green one, we have it only for bigger than 4. So I'm going to like find that 4. Notice it's an open circle. It's kind of hard to show, but I'm just going to maybe put a little open circle around. If you just have a point there, no worries. It's kind of hard if you can't color code. So I've got my points there, and they're all labeled. Some students find that they prefer to do this and like draw them all and erase what they don't need. Other times, another strategy you could do is like if I know that this is only for 4 and up, but not specifically including 4, I could also make a table and plug in like 4, 5, 6, and then get some points. Like it looks like 4 is 0, 5 is 2, right? 6 would be 4 up. So you could do an input-output table like so and get some points and use the 4 and up. For this one, I would do an input-output table, and I might do like -2, -1, 0. For the one in the middle, I might do 0, 2, and 4, right? I have to include 0 and 4, and I want to pick maybe one thing in the middle. So that's one way you also could do that. So really all a piecewise function is it's a function made up of parts of other functions. And now, somewhere else on your notes, I'm going to ask you a couple follow-up questions. So I'm going to pause and I'm going to write them out for us. Okay, so here are the follow-up questions that we're going to answer using this picture. So domain and range, some people had a little bit of trouble with this. I'm going to say you can use whatever notation you want. So I'm going to be using interval because I find that that is more useful for me. So notice interval notation, the lowest thing, I see this arrow, which means it's going to continue to negative infinity. I'm like looking from the blue to the pink to the green, and I have points for every single x value in that in between. And then the arrow that's going to the right signifies that it's just going to keep going up. So my domain is everything. I'm allowed to plug in any number. My range, I'm also seeing the arrow that's going up, right? Arrow that's going down into the left. So that means that unless there's any issues in between, it also will be all numbers, right? Notice as I look between these numbers, I do have points for every single x value. So it is actually negative to positive infinity. And then a little practice, f of 1, plug in 1 for x, right? What is the output or the y value? It looks like it's going to be equal to 3. And then if I try f of 0, now here's the question. Sorry about that. So here's the question. Is it equal to 3 or 4, right? I kind of see this point here and this point here. The answer is actually 3. It's not 4 because notice at 4 I have an open circle, okay? F of 5, I'm going to look over to 5. It looks like my output is 2. And all of these I've been looking at the graph, right? However, for something like f of 100, I have no clue where that would be. So what your strategy is you know it's going to be on the green chunk, right? The green chunk is going to keep increasing. So I'm going to be using the green equation and say, okay, that would be 2 times my input of 100, take away 8. So that would be 200 minus 8, which is 192. And you can do that if you don't have a clear point on your graph or anything. You just have to pick which equation that number would fall into based on the restrictions, and then that's how you get your output. So that's it for the video. Make sure you come to class ready with questions to ask tomorrow on Tuesday. And we're going to do some practice together. You'll have time to be working on the homework and ask questions as you guys come across them. So I'll see you guys tomorrow.